Good morning, everyone. Today we're going to go ahead and continue chapter 11 with our unit on area. And specifically today we're going to look at 11.4, which is the area of kites. So to start that, we're going to actually go ahead and explore a little bit. We're going to go ahead and decide what information we actually remember from kites. So to do that, let's go ahead and use this diagram right here. All I am asking you to do on this first challenge, guys, is ask you to write as many conclusions as possible. What I would recommend right now is actually you pausing the video, write as many as you can down, and see how many of them are similar to what I have after you've had a chance to brainstorm. So go ahead and pause the video at this time, guys. Please write down as many conclusions as possible. Alright guys, now that we're back, let's go ahead and see what are some of the ones that I came up with here. One of the biggest ones here, guys, that I remember is that in a kite, don't forget that one of the diagonals is the perpendicular bisector of the other, okay? And in this case, it's this right here. So BD perpendicularly bisects AC, okay? So remember, a kite has two sets of congruent disjoint sets of sides, and the diagonals actually are going to be perpendicular. And more specifically, one of the diagonals is the perpendicular bisector of the other. Hopefully it looks clear here, guys, that these two look congruent, and obviously these two pieces on this diagonal, like here and here, those don't look congruent. So only one of the diagonals is perpendicularly bisected. Okay, so I actually to express that, I set that right here. So to show that AE and EC are congruent, that's what I wrote here. And actually, since I mentioned perpendicular, I'm also using that right there. So BD is perpendicular to AC, or vice versa. AC is perpendicular to BD. And actually, almost as a consequence, guys, these two things end up happening because of that. All right. So if those two lines are perpendicular, what ends up happening is you create a bunch of right angles. So AEB, CEB, AED, and CED, all of those are right angles. And then because of that, almost as a consequence of that, because they are all right angles, we know that all right angles are congruent, meaning all of these angles have to be congruent. Let's see, what is another thing that we know from kites? Well, we also know that one set of opposite angles is actually going to be congruent, and actually these, all of angle ABC and angle ADC, they are not congruent. However, angle ABE, and actually let me highlight that in blue, angle ABE, oh, I actually said that wrong. Sorry, my fault, wrong one. Let me go ahead and rewrite that one. Okay. Oh, I see what I did. I never actually wrote it. I'm talking about a different one. So let's actually write this one down, guys. Actually, I did write it. It's my fault. It's up here. Okay. I thought I wrote it down. Alright, so those two angles right there, guys, those are going to be congruent right there. Now, hopefully it's clear to see that this angle, ABC, is not congruent to ADC. Because remember, guys, and let me go ahead and draw a kite off to the side. Remember, guys, that a kite could also look a little like this. It can have a really stubby short end, but then down here it could be super long. So hopefully this makes it a little clearer that this looks about congruent to that, but there's no way that this angle looks as large as that angle. So just keep that in mind, guys. In a kite, only one set of opposite angles are going to be congruent. Now, even though ABC and ADC were not congruent, each of their individual portions, so right here, for example, that diagonal BD actually bisects the angle. So let's say this whole thing was 40 degrees, then that means each of these are 20 and 20. Let's say this right here was 90 degrees, each of these would be 45 and 45. Okay, now that part is true, and that's actually what I wanted to say when I said these two final statements. Angle ABE is congruent to CBE, and angle ADE is congruent to CDE. So those are a lot of good characteristics from kites, guys. Hopefully you guys remember some of those, and obviously the obvious ones, like I said earlier, two sets of consecutive disjoint congruent sides. Okay? Alright, let's go ahead and move on from that, guys. But these are going to be super important, so let me do a little bit of erasing here, just so it is a little clearer, because we're going to definitely be using a lot of these characteristics as we move forward to the remaining part of this unit, or the remaining part of this section, actually. So let's keep going, guys. So the first task here is let's find the area of each kite. Well, I haven't really taught you guys what the formula is for the area of a kite, and we actually do have one that makes things kind of simple. However, we do have some tools at our disposal, and here's what we have. First off, I just said a second ago, guys, that one of the diagonals is the perpendicular bisector of the other. Do you guys see how 6 and 12 are not the same? So that's not the diagonal that got bisected. It's actually this diagonal that gets bisected. So this right here is 8, okay? Okay, so now what? Well, guys, don't overthink it. Even though you don't have a formula for kites yet, what do you have at your disposal? Hopefully you're noticing you have, let me try to get a thicker marker here. Hopefully you notice that, hey, that's a triangle. I actually have a base, and do you see how this is perpendicular to that base? That's actually a height. So I actually have at my disposal the ability to calculate the area of a triangle. The area of this blue triangle is going to be 1/2 the base times the height. Okay, so this is going to be, let's see, that is 12 times 18, 12 times 16. That's going to give me 8. 8 times 6 going to give me 48 units squared. All right, so now what? Well, that only gave me this top portion. Let me actually shade it now. That just gave me how much this is. Well, let's keep going then. Let's figure out what this is. Let's find out the area of this chunk of it. Because again, guys, remember, this is also a triangle, and I also have a base and a height. So let's go ahead and find the area of this red triangle. I have 1/2 the base, in this case the base is still 16, times the height, which is 12. So that's going to give me area of the red triangle. Let's see, that is 8 times 12, that's going to give me 96. Alright, and all I have to do now, that was the area of this green portion. So what do I have? Well, that's the whole kite, guys. That's the whole thing. So I have this green area here plus this yellow area here. So final answer, the area of the kite is going to be 48 plus 96 for a final answer of, if I'm not mistaken, that's 244 units squared. Okay, so even though we didn't really have a sorry, not 244, 144. I knew that sounded kind of off. 144 units squared. So even though we didn't really use a formula here, guys, remember, at the end of the day, these are broken up into things that we are familiar with, guys. Even rectangles. Rectangles can be broken up into triangles. We know the formula for triangles. Even a parallelogram can really be broken down into a bunch of triangles. So we have those tools at our disposal, guys. All right, let me move on to this one right here. Slightly harder. Now, as you guys can see, this and this, those are different size angles. One of them is 30, one of them is 45. What does that mean? That means this whole thing is 60. That means this whole thing is 90. Well, if that's true, then that means those are the angles that are not congruent. Those are not the opposite angles that are congruent. That would mean these are the opposite angles that are congruent in a kite. What does that also tell me, guys? That tells me that this right here is not the diagonal that gets bisected. It's actually this right here. That's the diagonal that gets bisected. So I'm going to go ahead and draw my tick marks here. Okay, and it's going to be helpful. Why don't I actually draw that I have a perpendicular bisector there, guys? Okay, because with that information, I should be able to figure out some good stuff here. Now let me do a little erasing here. I want you to concentrate for a moment, guys. I want you to concentrate on this because I'm noticing that I have two triangles here. I mean, there's a bunch more that I see, but if I can figure out the area of that red triangle and the area of this blue triangle, then I'm good. I can add those two areas up and get my final answer. Well, notice that I don't have much information here. I don't have any of the diagonal portions. I don't know how much this measures. I don't know how much this measures. So those are my heights for both of those respective triangles. And I actually don't have a height. Or sorry, excuse me, I don't have a base for either of them. I don't know how much this measures. But guys, there's got to be a reason why they gave us this information. Okay, so let's go through it. Let's go slowly, guys. Here we go. So, what do I know? And what am I trying to figure out? Well, I know that these are congruent. That's one part that I know. So I actually already know this right here. Basically, I know the base of both of the triangles that I'm going to try to find the area for. Now, if you look closely, you were given right here, let me see if I can get a thicker marker here, that this is 30 degrees. Now, what do you also know? You know that these diagonals are perpendicular one another. Okay, well, doesn't that green triangle, or sorry, that blue triangle show you a 30, 60, 90 degree triangle, guys? Hopefully you're noticing that. So this right here is 60 degrees. Okay, so let's do some work. If I want to figure out, for example, how much this measures, think about it, guys. Draw it off to the side. 30, 60, 90, and the only side that I know is the one across from the 30. Well, remember, guys, in a regular 30, 60, 90, 30, 60, 90, across from the 30 is x, across from the 60 is x root 3, and across from the 90 degrees is 2x. So what do I actually have? Well, I have what's across from the 30 degrees. So I actually know what x is. X is equal to 4. Okay? That gives us a lot of good information because that should tell me what goes across from the 60 degree angle. Across from the 60 is x root 3, so 4 root 3. And now I know how much this is. 4 root 3. Cool? All right. Let me change my focus here for a second. Now, concentrate for me on this pink triangle. Okay, look at that pink triangle, guys. All right, that pink triangle actually shows me a 45, 45, 90. 45, 45, and 90. Okay, do I have any of the info necessary? Yes, I do. I have one of the legs. And don't forget, in a 45, 45, 90, it's leg, x, leg, x, hypotenuse, x root 2. So what would it be if x is 4? Well, it would be 4 root 2. Okay, if I wanted to know that information. But the only one that I actually want, guys, I want this information right here. I want to know how much that is right there. Well, I know what it is now. Okay, I know what that is. It's right here. It's this portion down here. Okay, so I just found out what it is. It's actually 4. Okay, cool. Now, that was all almost like beginning work or kind of side work. Because, guys, now look at what I have. Let me do a lot of good erasing here. Now, what do I actually have? Well, let's concentrate on the triangles that I asked you to concentrate on earlier. Here's a red triangle. Can I figure out the area of that triangle? Well, yes, I can. Let's do it. 1/2 the base. Here's my base. That's 8. So 1/2 the base times the height. My height is right here. I now know my height is 4. So my area is going to be 4 times 4. That's 16 units squared. So the area of the red triangle is 16 units squared. Let's go ahead and concentrate now on the blue triangle. All right. So the area of the blue triangle is going to be 1/2 the base, also still 8, times the height, and in this case, guys, the height is going to be that 4 root 3 we found. So 4 root 3. So 1/2 of 8 is 4. 4 times 4 root 3 is going to give me 16 root 3 for a final answer of my blue triangle of 16 root 3. But remember, guys, at the end of the day, we're trying to figure out the entire area. So the area for this blue one, 16 root 3. The area for my red triangle is just 16. Add it all up, we find the area of the kite, which in this case would be 16 plus 16 root 3 units squared. Do not forget, guys, that we're dealing with area, so always, always, always unit squared. Okay? Okay, so here comes the hard part, and you really gotta kind of open your mind to this, guys, because it can be a little confusing at first, but as soon as you see it, guys, hopefully you guys will be convinced that this is a proper formula for a kite. So it says, can you create a formula for the area of a kite using diagonals? Okay, so here's what I want you guys to do. Very similar to what we did a second ago. I want you to concentrate on that kite and think of it almost like two separate triangles. Let's think of it as this triangle here and this triangle here. Now, I could draw some more information if I wanted to. I know that those diagonals are congruent. I'm sorry, those diagonals are perpendicular, my fault. And actually, this is the diagonal, the one diagonal that gets bisected. Okay? Now, let's say I wanted to find the area of the red one. Let me use my color red here. So I'm going to go ahead and find the area of that red triangle. But I'm going to use my letters here, and my just general statements. I'm not going to actually use numbers. So what is my base here? So my area for the whole kite would be the area of the red triangle plus the area of the blue triangle. So let me see if I can actually write that down. Well, the area of the red triangle would be 1/2 the base, which in this case is AC, times the height. Well, in this case, the height would be right here, BE. Cool. So let's write that down. Now, once I know that area, I have to add it to the area of the blue triangle, which would also have a base of AC, but now this time the height is actually ED. Oops. Okay. Cool. So all I did, guys, was use general statements here. Now, but what I want you to notice is this. Do you guys notice how these two things right here, right? Look at both of those terms here. Isn't it true that they share a 1/2 times AC, and the only thing that's really different is a BD and an ED? So what am I going to do? I'm going to do a little bit of algebra here, guys. I'm going to pull out that 1/2 AD, or sorry, 1/2 AC. So let me pull that out. 1/2 AC. Now, kind of like when we would do factoring, guys, like if I did something like this. I don't know, let's see. Let's say I had that, and I wanted to pull out a factor. Well, they have a 2 in common and an x in common, so what would be left over? 2 plus, let's say I did that, 2 plus 3x. That's what we would be left over. Well, what's left over in this particular problem? Well, what's left over here is going to be that BE, whoops, there we go, that BE and that ED. So what's left over is BE plus ED. Well, guys, look at your diagram again. Isn't this the first diagonal, AC? And hey, look at that. Isn't BE plus ED, BE plus ED, isn't that the entire diagonal here? So actually, what am I noticing? It says, can I write a formula using the diagonals of a kite? Well, I can. Here's the area of a kite, guys. Ready? 1/2 the first diagonal, so 1/2 times diagonal number 1 times the second diagonal, diagonal number 2. Okay, so right down here, guys, let's go ahead and write down our formula. Area equals 1/2 diagonal number 1 times diagonal number 2. That is our formula for the area of a kite. Okay, now, just because you guys know me and I like to kind of or rather I'd like to extend or supplement your guys' understanding of this, why don't we do this, guys? Let me actually show you something real quick. I'm going to try not to take very long, but I want you guys to concentrate on this right here. What if I moved that red triangle right here, and why don't I like flip it? Because can't I literally just lay AE and put it right here? Because aren't they the same? Wouldn't this be the same as that? So watch this, guys. What if I actually flipped it and stacked it right here? So basically what I'm saying, guys, is let me move this red triangle here. Okay, well, that red triangle is no longer there. Let me go ahead and show you that it's not there. Let's do a thicker thickness here. So check that out. That red triangle is not there. Why? Because I moved it and it now turned into a green triangle. Right there. Okay, cool. So now what? Well, let's try to do the same thing now with this triangle. Let's try to move that blue triangle, and let me actually flip it and put it here instead. So that blue triangle, guys, I just moved it and moved that over to the right. Now, guys, why would I do that? What did I actually do? Well, if you look closely, and sorry for this keeps appearing. I don't know why it keeps on appearing, but what did I just do, guys? Oh my God, seriously? Sorry about that, guys. Let's pretend for a second that this is in here. Okay, and actually let me zoom in this way so you guys can't see it. There you go. So what did I just do? Well, guys, I actually just created, remember how this was perpendicular like that? Well, I just created one giant rectangle. However, guys, the base is this. Well, actually, it's right here. This is the base. But do you agree that this right here was only 1/2 of the first diagonal? And isn't it true that the second diagonal is right here in its entirety? Hey, look at that. That's the formula for the area of a kite. Okay, so I'm not going to go into it too much further, guys, because I'm doing it at the risk of confusing you. So for now, let's just stick with what we know. And what we know as of right now is that the area of a kite is 1/2 times diagonal number 1 times diagonal number 2. Really doesn't matter which one you name, number 1 or number 2, but that is our formula, guys. Okay, I'm actually going to let you guys try your formula on this next problem. Here's what I will help you out with, though. Okay, the problem here is I don't have this information, I don't have this information, and I don't have, actually I do have this information right here, because remember, guys, one of the diagonals did get bisected, so I do have that. Okay, so I actually have diagonal number 1. Diagonal number 1, diagonal number 1 is going to be 18. Our task, or your task rather, I want you to find out how much this measures, how much that measures, and then just realize that diagonal number 2 is x plus y. It's that whole thing. So here's what I want you to do. I want you to use the tools at your disposal, guys. I want you to take the time to pause the video at this moment, find out what x and y are. You might need to use Pythagorean theorem. You might need to use your Pythagorean triples. Find out whatever way you need to, and then I want you guys to go ahead and do me a favor and calculate for me 1/2 times diagonal number 1 times diagonal number 2 to find my area. Okay, go ahead and pause the video at this time and give that a try. Alright, guys, I am back, so let me go ahead and show you guys the final answers here, or at least the way we set up. Problem number, doesn't even have a problem. Just this next practice problem, guys. So last thing I mentioned is for you guys to actually find for me that value and that value, because we need to know the second diagonal, guys. We need to know what this whole thing measures. So if you look closely, guys, on this first triangle, there was actually Pythagorean triple. This is a 3, 4, 5. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. So that was a Pythagorean triple, or you could use Pythagorean theorem, guys. You should have gotten 12 for that part. Now for this part, if you focus on this triangle for a second, guys, we don't really have a Pythagorean triple here. However, we have the quadratic, or sorry, not the quadratic formula. We have Pythagorean theorem. So we applied it here, and didn't work out as nicely as I wanted to, but we got an answer. We got 4 root 34. So what do I actually have now, guys? Well, we'd had the yellow diagonal, which was diagonal number 1. I call that 18, because 9 plus 9 is 18. Diagonal number 2 is a combination of 12 and 4 root 34. So 12 plus 4 root 34, I'm missing a little 4 here, 4 root 34. So let's calculate the area, guys. Here we go. Let's do it. Area is 1/2 diagonal number 1, diagonal number times diagonal number 2. So let's put values in here. Diagonal number 1 was 18. Diagonal number 2 is 12 plus 4 root 34. Okay, well, let's do this portion first. 12 times 18 is going to be 9. And then all I have to do now is distribute my 9 to both of those for a final answer of, let's see, 9 times 12. That's going to give me 108. Plus 9 times 4 is 36, and don't forget to attach that root 34. This is units squared after all, because we are looking for area, and that is it, guys. You can't simplify that anymore unless I told you guys to give me the answer to the nearest decimal. But for now, we can leave it as that, so let's go ahead and move on. Alright, let me go ahead and do this one. This is an important one, guys. You're going to be coming across something like this on your homework. So make sure that you're listening to this portion, guys. Make sure you understand how this works. So here's what I'm noticing. Okay, ready? First off, let's draw some stuff we know. We know that that's those two lines are perpendicular, which means that there's a bunch of right angles. And we also know that these diagonals, or that diagonal, got bisected. Because again, as you can clearly see, this is the diagonal that did not get bisected. Okay? Now, here's the problem though. I actually have most of my formula. And again, guys, it doesn't matter which one's D1 and D2. I actually already have the first diagonal. It's right here. 4 plus 16. 4 plus 16 is just 20. The problem is, what the heck is diagonal number 2? That's the hard part. Diagonal number 2 is here. Now, I have no idea what either of those two are. What I do know, however, is if that's x, then so is this. So whatever number goes here, that's what's going to go here. So basically, diagonal number 2 is going to be 2 times whatever x is. Okay? So let's go ahead and figure out what x is. Now, unfortunately, we don't have much information to go off of, guys. But I'm going to draw something for you guys, hopefully, is going to convince you of how to actually tackle this problem. For a moment, let's concentrate on just the top half of this kite. Just this triangle, guys. That should look super duper familiar. Let me show you why. Right angle, right angle, right angle. If I focus for a second on the big triangle here, well, I have no idea what the rest of the angles measure, but I do know that this one measures something, and this one measures something else. Starting to look familiar at all, guys? These are similar triangles, okay? The large one, remember, guys, we've compared the large triangle with the medium-sized triangle with the small triangle, okay? Large, medium, and small. And remember, because we already know for that baby blue triangle all the angles, well, let's see, what do I have? I have a black, oh sorry, my fault, wrong color. We have a black angle, the right angle. We have a black, a green, and a red. Well, then let's focus our attention on this little triangle for a second. I have a black, a green, but I don't have a red angle, so this is my red angle. if I focus for a moment on this green triangle, I have a black angle and a red angle, but I'm missing a green angle. Okay, guys, these are similar triangles. Do not forget that topic. Similar triangles. All three of those triangles are similar by angle-angle similarity. Okay, what does that mean? Then I can set up corresponding ratios of corresponding sides of each of those similar triangles, right? Okay, because similar triangles always have corresponding ratios. So let's go ahead and write those down. So here we go. Let's concentrate for a moment, guys, on the, well, let's see. The big triangle doesn't have this, and does have that. It has a side of 20, but that's one piece of information, guys. That's not good. The little triangle has two pieces of information, here and here, and the medium-sized triangle has two also pieces of information, here and here. Guys, we can set up a proportion with that, okay? Corresponding sides are proportional in similar triangles, so let's set up a proportion. Well, 4 over x, I'm concentrating on the, let's go ahead and highlight it in green here. I'm concentrating on this triangle right here, guys. So what did I do? The side that is green and black, compared to red and black, which is x. So let's do the same thing here. For the yellow triangle, what is the angle, or sorry, what is the side that corresponds to the angles green and black? So green and black, that would be x. And then red and black would be 16. Okay, exactly what we did in the past, guys. All right, we just set up our ratios here. We set up a proportion. All right, corresponding sides of similar triangles are proportional. So now we can do our cross multiplication. That gives us 64. Take the square root. That gives us x equals. Now technically this is plus or minus 8. But remember, guys, we're dealing with the measure of a side here. We can't say it measures -8. So our only answer is x equals 8. So after all of that, we can now come back and focus on our original problem. These were the same. We now know what each of those are. They are 8, and that's all I need, because I needed diagonal number 2. Let's replace diagonal number 2 with what diagonal number 2 actually is, which is 16. So let's finish off this problem, guys. The area of this kite is going to be 1/2 times 20 is 10. 10 times 16 is 160 units squared. Okay? Cool. All right, so let's move on, guys. Hopefully we can wrap this up pretty soon. The question here, guys, says, to what other shapes can we apply this formula to? So think about it, guys. What other shapes have similar properties to a kite? And more specifically, guys, we use this important property right here. Okay, we use one, or actually two big ones. That the diagonals are perpendicular, and that at least one of the diagonals gets bisected. At least one. I mean, it could, obviously it doesn't hurt us to have both of the diagonals get bisected, but do we have at least one of the diagonals get bisected? And actually we do, guys. If you stop to think about it real quick, we do have other figures and other shapes that we can apply that to. And here's one. Okay, what is another shape or another quadrilateral that has diagonals that are perpendicular and diagonals bisect each other? Well, actually that happens in a kite. Oh, sorry, my fault. Of course it happens in a kite. That's the formula we use. Sorry, that happens in a rhombus. And actually, what is a figure that is under a rhombus, so a product of a rhombus? That means it also works for a square, which it sure does. In a square, diagonals are still perpendicular. Sorry for my horrible drawings here. And the diagonals actually bisect each other to the point where actually all of those 4 pieces would be congruent. Okay, so actually, guys, we can use this in 2 other figures, in a rhombus and a square. Okay, so just keep that in mind, guys. It might be helpful as we move on to a few more problems. All right, I'm not going to do all of these. I think this one is just a review. Number 3, guys, is almost the exact same thing as this problem. So I'm going to actually let you guys do that one on your own. I'm probably going to have to do the remaining ones here. Let's go ahead and look at number 1. So here we have a rhombus. Okay, that means if it's a rhombus, just like I said earlier, if it's a rhombus, I can actually apply this formula too. So I need area is 1/2 diagonal number 1 times diagonal number 2. Well, I do have diagonal number 1. It's right here. That's 10. Here's the problem though, guys. I don't have diagonal number 2. Okay? I can draw a diagonal here though. Now, this is a rhombus. What does that mean? That means diagonals are still perpendicular to each other. And in a rhombus, the diagonals bisect each other. So this is congruent to that. This is congruent to this. How did that help me, guys? Let's go ahead and try to figure that out. How does that help me? Well, this big section of 10 is now split up into 2 pieces. This is 5, and this is 5. So here's what I want you to do. I want you to concentrate your attention, guys, on one of these triangles that I just created. Let's focus on this triangle right here. Look at it closely, guys. This is a right triangle with 2 missing sides already found. I'm just looking for this third one. Let's call it Y. This is a 5 blank 13. This is actually a Pythagorean triple, guys. This is a 5 12 13. So no need for the Pythagorean theorem if you don't want to use it, because this is actually a Pythagorean triple. So my answer for Y is going to be 12. Okay, so Y is going to be 12. Well, what does that mean, guys? Well, if that's 12, then this is 12. So what do I actually now know? I know the second diagonal. 12 plus 12 is 24. So let's go ahead and put that all in the formula, guys. 1/2 diagonal number 1 was this whole thing, that was 10, times diagonal number 2, we just found out what that is. 12 plus 12 is 24, for a final answer of 5 times 24, or 120 units squared. Okay? Next one. Guys, this one I'm going to tell you right now, yes, it's a rhombus. Yes, you could find the diagonals. Yes, you could still apply the same formula as a kite, but no need. Let me show you why. A rhombus is still technically a parallelogram. Our formula for the area of a parallelogram is going to be base times height. Guys, don't go any further than that. You have the base. Let's call this my base. But if I have a base and I call that the base, I better have another segment that's perpendicular, so it works as my height. Well, I do. Right there. Base times height. Easy as that, guys. Don't overthink it. Base times height. Area is 160 units squared. That's it. Or, kind of like I showed you guys very briefly, not very much, but I did show you guys. What if I move that triangle right here? And this is actually why so many formulas are tied back to that original formula for a rectangle. Guys, look at what I just did. I just moved this red one, and I moved it over. And of course, it's going to keep showing up. But I moved it over, guys. And if I move it over, didn't I just create one giant rectangle? Okay, base times height, 20 times 8. Okay, so that's how we got our final answer there. And like I said, guys, I'm going to skip that number 3. It's very similar to one that we just did earlier. Here is the last problem for today, guys, because I didn't want to make this video that long. However, it is definitely going to be a long one. Okay, here's what I'm going to do. This one right here, guys. Let's go ahead and draw that second diagonal right there. Now, This first diagonal got split up in half, so this is 6, this is 6. So I actually already have part of my formula. 1/2 diagonal number 1, which is 12. I just need diagonal number 2. I need to figure out what does this measure. And to do that, you got to remember another property of a kite, guys. Okay? Another property of a kite is that in a kite, let me draw that diagonal again. In a kite, one of the opposite angles, whoops, sorry about that, guys. Sorry, guys, my computer kind of freaked out there for a second. Let's see if I can go back to that. So the diagonals actually bisect the angles. So this got bisected, this got bisected. Now what does that mean, guys? That means this is now 40 degrees. And actually, I'm going to concentrate for a moment on this triangle here. Okay? Okay, what else do I know? Well, I know that those diagonals are perpendicular. And what I'm actually going to do is I'm going to ask you to also concentrate on this triangle. Now, why am I asking you guys to do that? Well, guys, the reason why I'm asking you to do that is because you need to find two pieces of information. I need to know what that is, and I need to know what that is. Because if I know what x and y are, I can figure out what that diagonal is, which means I can finish my formula right here. Well, guys, we only have a side, and we have an angle. When we have an angle and a side, you have to use some trig. You have to use some trig, guys. Okay? So how do I find that missing x? Well, here we go. What uses opposite, that's the opposite right there, and adjacent, because I don't have a hypotenuse. I don't know what this hypotenuse is over here. I have no idea. Okay? So if I have no idea what that is, then I'm going to concentrate on using opposite and adjacent. What uses opposite and adjacent? Well, that would be tangent. So the tangent of 40 is equal to opposite over adjacent. Let's solve and get the x by itself. We can now cross multiply. This gives me x times the tangent of 40 is equal to 6. I don't like the tangent of 40 next to my x. I'm going to divide it. And I know this looks kind of ugly, but the answer here, guys, is 6 divided by the tangent of 40 degrees. Okay? I just found what x is. Kind of ugly, but go ahead and leave it as that for now. Well, very similar down here in this pink triangle, guys. Check it out. This got bisected, so this is 25 degrees and 25 degrees. So what do I also have? I also have the opposite, and I'm looking for the adjacent, and no need for the hypotenuse. So again, what uses, whoops, oh, my computer's working slow. Sorry about that, guys. What uses opposite and adjacent? Well, tangent again, guys. The tangent of 25 degrees, remember that's the angle now, 25 degrees, is equal to opposite over adjacent, 6 over y. Very similarly, guys, let's cross multiply here. Y times the tangent of 25 equals 6. Again, I don't want that tangent of 25 there. So I'm going to divide it by the tangent of 25. Just like that. Okay? So this is going to give me final answer, y equals 6 over the tangent of 25. Now this is ugly, guys. I don't particularly like the way this looks. However, I now know what diagonal number 2 is. Okay, that's the one that was missing here. So diagonal number 2 is those two put together. Okay, those two added. X plus y. 6 over the tangent of 40 plus 6 over the tangent of 25. Now notice I didn't actually divide that out, guys. I don't want you to round here. I do want you to eventually round at the end though. So here's diagonal number 2. I'm going to write that in here. So let's rewrite this whole formula out one more time, guys. Ready? Area equals 1/2 times 12 times diagonal number 2, which was 6 over the tangent of 40 plus 6 over the tangent of 25. Guys, you got to be really careful how you actually type that in your calculator, or if you want to do it in chunks, you may, but try to only round at the very end, okay? So don't round anything until the very end, and if you do that, guys, if you do that for a moment, you should get approximately an answer of 120.11 units squared. So I'm going to let you guys take the moment to double check your work on that. Well, for now, guys, that's exactly 45 minutes on our video here, exactly what our class period would be, so I'm glad I was able to stay under that. So for now, guys, I'm going to sign off. As always, please email me if you have any questions, but for now, go ahead and rewind the video if you need to, but other than that, we are pretty much done with 11.4. Alright, guys, have a great day. I will see you on the next one.